Hi everyone, I welcome you all in the quick solutions of All India AIATS Test Series Medical 2019, and I am here with the test number 5 code A and B, and we'll be discussing the chemistry section. Let's begin with the question number 46 of chemistry section. A certain gas takes half of the time to fuse out as taken by gas neon under similar conditions of temperature and pressure from a hole. Its molecular mass will be. This is a simple question based on Graham's law of diffusion, and in this case a certain gas is effusing and its rate of effusion is compared with another gas, that is neon gas. Let's solve this question. We know that rate of effusion for that particular gas is inversely proportional to its molecular mass, and we are just comparing two gases. That's why we can directly take the formula that R gas upon R neon, rate of effusion for neon. If you are considering the time also, so the volume of effused gas divided by its time is the rate of effusion, and similarly if we talk about the rate of effusion for neon, this would be V by T for neon also, and should be equal to root of molar mass of neon divided by the root of the molar mass of that particular gas. And in this case, we know that it's clearly given here that that gas takes half of the time to effuse that was taken by neon gas under similar conditions of temperature and pressure. It means in this case the volume is same, that we can assume, and the time taken by neon is supposed T. Then definitely the time taken by that gas is half of that as per the question, so it can be written as this. Now here's the molar mass of neon you have to take in root. So the molar mass of neon, we know that is 20. It's divided by the root of the molar mass of that particular gas. Now in this case it can simplified to 2, that's equal to root of 20 divided by root of the molar mass of that particular gas. It means this molar mass of that gas is equal to 20 divided by 4, and it is 5U. It means the imaginary gas that you are assuming here has the molecular mass that is 5 gram per mole. Now this is the molar mass of that particular gas, and in this question they are asking you that what is the molecular mass of that gas. So definitely the molecular mass of that gas is 5U, and that's why I'm choosing this as the correct answer. Now after this, let's take next question. Question number 47. Amount of oxygen gas present in 2-liter vessel at 5 atmosphere pressure and 27 degrees Celsius is. We have the amount of oxygen given in the option in terms of moles, and here we will use the simple formula of ideal gas equation, that is PV is nRT, and we just want to find out the N value here. Pressure we have, that is 5 atmosphere. Volume we already have, that is 2 liter, because the volume of the vessel is given, that's why we can say that the volume of the gas is 2 liter. Further, and we need to find out the R value is 0.0821. Further, the temperature is also given, that is 27 degrees Celsius. It means 300 Kelvin. Now, what would be the value of N? This N would be equal to 5 into 2, 10 divided by 0.0821, 300. So, if you solve this, you will find out it is 0.4 mole. This would be the answer, and this answer is given here in question 3. So the correct option for this particular question is option 3. Now let's move on to the next question. Question number 48. Select the correct statement for isothermal expansion of an ideal gas. We are talking about process of expansion of an ideal gas, and this process is isothermal also. We should always know that whenever we talk about isothermal process, there is the temperature that is constant. The first thing that you should remember. And whenever the temperature is constant, definitely the internal energy of the system is also constant. It means this delta U is 0 for this particular case. And we are talking about the expansion process. It means pressure is reduced. So let's check the options to find out the correct one. First is internal energy decreases. Internal energy remain constant, so that's why this option is wrong. Further, temperature remains same. We already discussed this temperature remains same, it means this is correct statement. But let's check further option also. Pressure increases, it is not possible because this is isothermal expansion process. This is also wrong. And kinetic energy increases, this is also the wrong statement. Which statement is correct now? Only the option 2 or the statement 2 is correct. That's why I've chosen this as the correct option. Let's take next question. Question number 49. Standard enthalpy of formation is non-zero for. We have different substances given in the options. Let's check. First we have O2 gas. We should always know that standard enthalpy of formation. This remain 0 for the most stable allotrope of the element. Now, in this case, if we talk about O2, this O2 is the most stable allotrope of oxygen. It has the standard enthalpy of formation 0. Similarly, if we talk about P4, white phosphorus, and for this also, the standard enthalpy of formation considered as 0. So here I'm marking 0, here also 0. S8, the rhombic sulfur we are talking about. This also has the standard enthalpy of formation as 0. Now, if we talk about red phosphorus, it does not have the standard enthalpy of formation value 0. That is why this is the correct answer, because it has standard enthalpy of formation that is non-zero. So, the correct answer that I can write here is option 4. Now, after this, let's take next question. Reaction for which Kp and Kc are equal. What's the relation between Kp and Kc that you should know? Kp is equal to Kc RT raised to the power delta N G. It means we are just going to talk about the gaseous moles here, and we need to find out this delta N value. That delta N value is N2 minus N1, where N2 is the number of gaseous moles of the product and N1 is the number of gaseous moles of reactant. So if we talk about the first case, in the first case, first option basically, nickel is combining with 4CO, that is nickel carbonyl. That is the process of formation of nickel carbonyl here, and in this case the gaseous moles of reactants are 4 while the gaseous moles of products are 1. It means this delta N G value in this particular case is minus 3. After that we have the next option where we need to find out the delta Ng value. In this particular case the gaseous moles are, in this particular case this value is minus 1. Further, in the next case, third option, we have this delta Ng value that is equal to 1 minus 2. It means again minus 1. Next case, this delta Ng value where 1 mole of NO gas is there and half mole of N2 and half O2 are combining. If the number of moles of reactants are 1, number of moles of products are 1, it means this delta Ng value is 0. And if this Ng value is 0, for particular case, for option 4, if we consider this Kp value, that would be equal to Kc RT raised to the power 0. It means in this particular case, Kp is equal to Kc, and that case is given in option 4. That's why this is the correct answer. So I'll write here the correct answer.